Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to talk about the derivatives of inverse functions. Let's start. In most textbooks, you'll see a list of formulae given you for the derivatives of functions and inverse functions. So you probably have already seen the rules for the derivatives of inverse trig functions. In some exams, you're allowed to use formula sheets, so you don't have to commit to memory. But perhaps in some exams, you still have to, make use of some technique to commit to memory, looking at patterns. The derivative of sine inverse and the derivative of cosine inverse, they are only differing by that negative sign for the derivative of cosine inverse. Also, in some cases, you use this term arc sine of x for the for sine inverse. Okay, so arc sine of x for sine inverse, arc secant x for the secant inverse, arc cosine x for the cos inverse. So those are just terms, and we also want to talk about notations. Okay, so something that I wanted to clarify about notations. So one thing was about the terms. The second thing was about the notations. In algebra, when we see x to the power of a -1, that -1 as the index, we know that this actually refers to the reciprocal. This is reciprocal of x. This is algebraic terms, right? Any number to the power of a -1 is 1 over x. But in terms of functions, this is sine inverse. So if you see something like this with a negative sign, f inverse of x, that's not the reciprocal, okay? Because, that's the problem with these notations, okay? When you see that, this is the inverse of f of x. And what do we mean by that? We know, we've already seen in an earlier video how to find the inverse. So if you're given, f of x is equal to some algebraic expression like x plus 3, then we know that we interchange, okay? So this is the y value, y is equal to x plus 3. You interchange x and y, and you get x is equal to y plus 3, and the new y is what becomes the inverse, right? So we got y as x minus 3. This becomes the inverse. That's the idea of the inverse function algebraically. Reciprocal of a function, if this was the fx was the original function, the reciprocal is just 1 over f of x. So these are just some notational things we need to be careful about, okay? Some of the notational things, okay? So f inverse with that negative sign is not the same thing as the reciprocal. It actually means the inverse, and that's the algebraic process. To find the derivative of the inverse, you can do this thing, okay? You can just use the algebra, find the inverse function, and then differentiate it. You can use any of the rules. If it turned out to be a composite function, you use a chain rule. If it was something simple like this, like an algebraic function, you can just find the derivative of using the power rule, and then you're done. Or if it was one of these functions, like the trig functions, then you can use these functions in conjunction. If there's a product of different functions, you can use that. But there is a certain type of question. I've seen this only in the AP exams, but you never know. You can face this question anywhere, okay? So this is just given in tabular form, okay? You can look at this question, all right? It's a function given in a tabular form. Nowhere have they defined f of x as an algebraic expression, okay? So the question reads, the table below gives values of the differentiable functions f, g, and f prime at the selected values of x, okay? So that's what we see. The first column is x is equal to 1, 2, 3, 4. And the second column basically gives you the values of the function f. Then the third column gives you the value of f prime at that particular value of x, okay? So when x is equal to 1, x is equal to 3, and f prime of 1 is -3. So when x is equal to 2, f of 2 is 1, and f prime of 2 is a -2. All right, so that's how you to read the table, okay? So f is a function, f prime is a new function. Remember that, okay? They are two different functions. But what is g? They said g is the inverse. So that's a third function. F is the original function. F prime is the derivative of that original function. G is the inverse of that original function, okay? And the question we're looking for is to find the value g prime of 1. In other words, they're asking us to find the derivative of f inverse of 1. I hope that is clear, because g represents the inverse, right? Inverse of the original function. So you're asked to find the derivative of f inverse. All right, so that's what g prime indicates. Okay, g prime at 1 at a particular value. But again, you don't have the algebraic definition, right? We don't have the algebraic definition of f. Otherwise, like I said, you could have just found the inverse using that, interchanging the swapping rule, and then clearly we can find this. So in order to solve a question like this where the definition is not given, we have a new definition for the inverse function, and it comes from this idea. All right, it comes from the idea that all these three sentences mean the same thing. When you say gx is the inverse of a function f of x, notationally we write g of x is equal to f inverse of x. Okay, just like we saw in the question. But this is also a very important condition. Okay, we've seen this in the video that I'd done earlier on inverses and composite functions. The idea of the inverse using composite functions is f of g of x is equal to x. The composite function f of g of x is equal to x, and g of f of x is also equal to x. So these are all equivalent. Okay, that means f and g are inverses of each other. F of its inverse is equal to x. That's the meaning of it. All right. So in that sense, there is another formula which says that the derivative of the inverse is the reciprocal. 1 over means reciprocal. It's the reciprocal of f prime, the derivative of f inverse of x. This denominator is a composite. Okay, this is a composite. It's the composite function f prime of f inverse of x. So we are going to use this formula in questions like these to solve a question like this where actually the definition is not going. Let's see how to do this. Okay, first let's go over the table again because we want to find the derivative of the inverse at a particular value, right? So we need to find out using the formula. If I just write down the formula, we'll write this as this is 1 over f prime of f inverse of 1. Right? That's the composite function, as I said, in the denominator. So we want to find what's this term inside, right? F inverse of 1. Let's look at the table. When x is 1, f of x is 3. We already said that, okay? So the inverse goes the other way around, correct? F of 1 is 3, so f inverse of 3. Let me write that thing down, okay? So I can say f inverse of 3 is equal to 1. Likewise, when x is 2, f of 2 is 1, which means f inverse of 1 is 2. All right, that's the idea of swapping x and y. When you swap x and y, that algebraic process of finding the inverse, this is what happens. Okay, the interchanging of the domain and the range. So when x is 2, f of x is 1, which means f inverse of 1 is 2. And in the same way, continuing in the same way, we can write down f inverse of -5 must be equal to 3 and f inverse of 0 must be 4. So now we are interested in what do we have? We need f inverse of 1. So we can just look at this thing and say, okay, f inverse of 1 is 2. So we are literally finding out 1 over f prime of 2. And that is again from the table when you read it off. So when x is 2, f prime of 2 must be -2. So our final answer should be just 1 over a -2. Okay. That's how we find the derivative of the inverse using this wonderful formula, okay? And this is applicable only in such situations where you're not actually given the definition of a function. The second part of this question was to write the equation for the tangent line to f inverse. Remember, f inverse is a new function. It's a new function. So you're finding the equation of the tangent line to this new function again at x is equal to 1. So the slope of the tangent line we've already found. The slope of the tangent is basically the derivative at that particular point. So I'm just going to write that down. M we've already found as a -1 over 2. And remember they said at x is equal to 1. For this function meaning for the function f inverse. So don't get confused and say, okay, you know what, x is equal to, don't take these values for f inverse, which means we're looking again here. All right, for this value. So when x is equal to 1, the value of y must be 2. So the point we're looking at, just write down, the point we're looking at is 1, 2. All right, that's because the tangent we are looking for is it's tangent to f inverse. Okay, that's the function. So then using the point slope form, we can write the equation of the tangent, as y minus 2 is equal to m x minus 1. Okay, I hope you understood how we took this point 1, 2. It's for this function f inverse and not the origin function. Okay, not the origin f of x. So then when we simplify this equation, we can write it as y minus 2 is equal to a -1 over 2x plus a 1 over 2, and that would then be y is equal to -1 over 2x plus a half plus a 2, and that makes it y is equal to negative x plus, that should be a 5 over 2, I believe. This is the equation of the line that is tangent to the inverse function at x is equal to 1. So this is a great definition to know because, we have all these formulae given to us, and we can also, like, if the function was defined, we could have just interchanged x and y and then found the inverse function and then found its derivative and then plug in the value for x is equal to 1, and that would still be the derivative of the inverse function at a particular value. But this particular definition that we saw today, this is really helpful when we are not given the algebraic definition for a function and you're still required to find the derivative of the inverse function at a particular value. So they are giving you some information, like in this case, we saw the table of values. So the derivative, this formula again, let me remind you, d by dx of f inverse of x is the reciprocal of a composite function. This is the composite, okay? Don't forget that it's f prime of f inverse of x. If you found this video useful, please do not forget to like, share, and subscribe to this channel. I'm going to see you all in the next video.